The next property is called the sum and difference property. The sum and difference property enables us to find the derivative of a function that is a sum or difference of two other functions. So to do that, we can just distribute the derivative over addition or subtraction. So the derivative of u of x plus or minus v of x is just equal to the derivative of u plus or minus the derivative of v. Now let us apply that to the example here. To find the derivative of the function f of x, given that f of x is equal to 3x cubed plus 11x squared, we just have to differentiate each of the function here. So f prime of x is just equal to the derivative of this, which is equal to 3 times 3 times x to the 3 minus 1, plus, copy the constant multiple property, 11 times the power here, 2 times x raised to 2 minus 1. And then simplify it. So you have 9x squared plus 22 times x. Now let's apply the sum and difference property, the constant multiple property, and the power rule to each of the functions here to find their derivatives. So for letter A, what we need to do is, to get the derivative of f with respect to x, is differentiate each term of the polynomial function here. The derivative of 3x to the fourth is equal to 12, because you multiply 4 times 3, that is 12, times x to the 4 minus 1 is 3. For the second term, you copy the sign, so minus, and then you have 2 times 3, or 3 times 2, which is 6, times x to the 3 minus 1 is 2. Third term, copy the plus sign, so plus, then you bring down 2, so this is just 2 times x to the 1, so this is just x because 2 minus 1 is 1. And for this term here, the derivative of negative 5x is just negative 5. So negative 5. And the derivative of a constant is just 0. So this is the derivative of the function here. Letter B. Y prime is equal to, now just differentiate each term. The derivative of the constant here is 0. So you don't need to write that. And for the second term, the derivative is, you multiply negative 7 and 2, negative 2. So negative 7 times negative 2 is 14. X to the, then subtract 1 from negative 2. Negative 2 minus 1 is negative 3. You may leave your answer like this. For letter C, before we can differentiate this, let us first rewrite the fourth root of v. So our function is equal to 5v cubed minus, now the fourth root of v in exponential form is just v to the 1/4. Then now you can differentiate each term. So differentiating each term, you have 3 times 5, which is 15. And then copy v, subtract 1 from the power here. So 3 minus 1 is 2. And then minus, you bring down 1/4. So you have 1/4 v to the 1/4 minus 1, which is negative 3/4. And lastly, for letter D, let's rewrite first each of the term here so we can use the power rule. So we are going to get the derivative with respect to x of, so we have negative 3 over 4 times x to the negative 1. So we use the property 1 over x to the n is equal to x to the negative n. And then the second term is 4x to the negative 3. And the third term is negative 1/8 x to the 4th. Then you differentiate each term of the expression here. So the derivative will be negative 3/4 times negative 1. So you multiply the constant here and the power here times, and then you subtract 1 from the power here. Negative 1 minus 1 is negative 2. And then you have positive 4 times negative 3 is negative 12. And then x to the negative 3 minus 1 is negative 4. And then 1/8, copy 1/8. Multiply that by 4, the power here, times x to the 3. So 4 minus 1 is 3. And then you simplify further. So negative 3/4 times negative 1 is positive 3/4. So positive 3/4 to the times x to the negative 2 minus 12 x to the negative 4 minus 1/8 times 4 is 1/2 x cubed. Next, let's find the slope of the tangent line at the given points, or that is also the same as finding the derivative at a particular value of x. So find f prime at x equals 2 if f of x is equal to 3 minus x cubed over x to the 6. Now to differentiate this, since we don't have any other formula, we just hope to use the power rule and the constant multiple rule. So to do that, we have to rewrite the given expression here first. So to rewrite this, we just need to divide each term by x to the 6, or we're going to split the expression here. So we're going to write this as 3 over x to the 6 minus x cubed over x to the 6. And then we use the property x1 over x to the n is equal to x to the negative n. So the first term will then be equal to 3x to the negative 6, and x cubed over x to the 6 is equal to 1 over x cubed. So you have 1 over x cubed here. And then this is just equal to 3x to the negative 6 minus x to the negative 3. So now we've written everything in their exponential form. Now we're ready to find the derivative of the function at x. So the derivative of this is just 3 times negative 6, that is negative 18, times x to the negative 6 minus 1 is negative 7. And then here we have negative 1 times negative 3, so that's positive 3, times x to the negative 3 minus 1 is negative 4. The next is to evaluate this function here at x equals 2. So let's evaluate the derivative at x equals 2. Now it's easier to evaluate it when you express the exponent in positive form. So you have to do the reverse for the definition here. This first term here will be written as negative 18 over x to the 7 plus 3 over x to the 4th. And then plug in 2 to 7. So you have negative 18 over 2 to the 7 plus 3 over 2 to the 4th. And then you use your calculator to simplify this. This is equal to 3 over 64. Next, we find the slope of the tangent line to the function here at t equals 8. Or, in other words, find the derivative of the function at t equals 8. Now, in order to find the derivative of this function here, we need to rewrite this expression first in exponential form. In here, we are going to use x to the n over m is just equal to the mth root of x to the n. And we also use this property here wherein 1 over x to the n is equal to x to the negative n. So applying that to the first term becomes negative 5 t to the 1/3. And the second term here becomes positive 6 t to the negative 1/3. So now that we've written this in exponential form, we can now proceed and find the derivative. The derivative of f with respect to t is equal to negative 5 times 1/3 is negative 5 over 3. And copy t. Now 1/3 minus 1 is negative 2/3. Plus 6 times 1/3. So 6 times negative 1/3 is equal to negative 2. So that's negative 2 t, and then negative 1/3 minus 1 is negative 4/3. And then to find the value of the derivative at t equals 8, we just have negative 5 over 3, 8 to the negative 2/3 minus 2 times 8 to the negative 4/3. And you plug this into your calculator. In your test, you are only allowed to use the calculator provided in the test, and that is actually the ClassCalc Scientific Calculator. I'll go ahead and show you how you can use this ClassCalc Scientific Calculator. So let's go ahead and plug in these values here to the ClassCalc Scientific Calculator. So you have negative 5 over 3, so it's going to be a fraction. So you have 5 divided by 3, that's how you make a fraction, times, and then you just put the cursor here in the middle, 8, so t is 8, to the negative, and this is the power, negative, and the power is also a fraction, so you put the parentheses there, negative 2/3, 2 divided by 3. And then enclose it, so put it in the middle, enclose it in a parenthesis, and then put this again in the middle. Then you have negative 2 times 8 times 8 to the negative 4/3. So to the, and then you enclose it in a parenthesis, negative 4 divided by 3. And then close it. So if you want to find the exact number, so you change the format here to fraction, you have negative 13 over 24. So in other words, the slope of the tangent line at t equals 8, or f prime of 8, is equal to negative 13 over 24.